Greetings everyone and welcome back to the bench. Today on the bench we're going to talk about the JAT801 or the JAT801 amplifier project. This is a preliminary design. I should caution you right off not to use the schematic because it's preliminary, it's not finished. There's part numbers, part values, even some small changes to the design that have to occur yet, but it represents what I want the JAT801 to be. And what I want it to be is a higher power version of the 501. This is the 501 amp here, which I am just delighted. It's my first amp design. I read a lot of material from other amp designers. Like I got Bob Cordell's amplifier design book. Looked at some other designers as well, see what they've done. I didn't just want to copy verbatim somebody's design. I wanted to create my own. But it is a 3-stage power op amp geared for music use. It has the differential input stage, voltage amplification, and output stage. And sure, you can go to their books and see the similarities, but the amplifier is not exactly like theirs as well. You might look at my input stage here and say, well, in Bob Cordell's book, he uses the same emitter degeneration resistor. Did you just copy those? Well, actually, when I designed this, I didn't have his book. I did look at a previous revision of his book, and he had different values in here. I chose these values because they're just middle-of-the-road safe. If I had a distortion analyzer, I can tinker a lot more with the circuit. Maybe bring down the distortion at higher frequencies. But looking at the tests I did perform with my limited equipment, I was really impressed with what I saw. And if you watched my design series of the amplifier, I did get pretty impressive numbers. Like I say, I wasn't going after 0.00001, stuff like that. I think it's completely pointless to do that. I mean, it's fun to be able to design an amplifier that can get super low distortion, but in actual use, I think it's kind of pointless. This amp, well, what I mean, the 501, at 1 kilohertz, the lowest I could measure was 0.005% at 1 kilohertz. But that was the same amount of distortion on the signal going in, so I don't know what its real performance is. And when I performed the intermodulation distortion test with an 18 and 19 kilohertz signal, I was getting pretty impressive values there as well. And of course, I performed the step response test, loading the amplifier with pure capacitance on its output to see how stable it would be. And it's just a nice performing, stable amplifier. And it's been really neat getting feedback from people who actually build it. Some people are more further along than I am. I just still have the cards here. I haven't actually finished an amp. Some people have finished the amp completely with their own power supply, a nice looking case and everything. They send me photos, tell me about it. It's kind of the whole idea for doing this. I wanted to design an amp, just make it available for whoever wanted to tinker with it. But anyhow, let's get back to the 801. Like I say, just a higher power version of the 501. Pretty much uses the same differential input stage. Not a lot of changes there. Minor changes to the voltage amplification stage. But the big change is to the output stage, where I'm going to have paralleled output transistors. Because I'm running at higher supply voltages, I have to select different driver transistors than what I used in the 501. One problem I'm having, I find transistors and then they're not available. I have a list of different transistors I've looked up and researched. I have to go back again. It was last summer when I was doing this, so I'll have to see if stuff's available now and what else they have. And if you're looking at this, you'll see, where's the pre-driver transistors? Well, I don't believe we need any. If you want to argue why you think I should have them, that's fine, but I don't think it's necessary. If you use these modern output transistors, they have decent gain. They don't suffer as bad beta droop at higher currents. Same with the drivers. If you use higher gain, and they don't suffer the beta droop. I don't see any reason to complicate the design any further. And again, if I was going for super low distortion, I would consider that. I will increase the current in the voltage amplification stage so that there's more current for the drivers to be able to drive the output stage. Apologies there, my battery quit on me when I was yakking. I'm not sure where it left off. So I was talking about the current in the voltage amplification stage. Now when I was running tests, I wanted to be sure that the output stage for the 501 wasn't being starved for current when it's driving difficult loads. So I'm running enough current but nothing more because I want to keep the distortion down. But in this design I will just go up a few milliamps. It's not like I'm doubling or tripling the current. And I think that will be enough for driving the output stage here with the higher power amp. So what kind of power am I looking at here? Well, with the 501, it was a 50 to 60 watt amp with 8 ohm loads, and 80 to a little over 100 with 4 ohm loads. It all depends on your power supply voltage. With the 801, I'm looking at maybe 120 to 150 with 8 ohm loads, and probably up to 200 with 4. I don't really want to go beyond that. You have to consider the output transistor's safe operating area. So I do want to stay within 200 watts with 4 ohm loads. Now if you're only going to use the amp with 8 ohm loads, you can certainly increase the power supply voltage so that you can get 150 watts or maybe a little more with 8 ohm loads. Because of the much higher current with 4 ohm loads, I have to draw the line somewhere and say about 200 watts would be the limit. Okay, back again with a little JAT sketch here. Nice lovely colors, that ought to count for something. It's actually several days later. I meant to put this video out before the end of the year, but I had some other stuff come up. I had to delay it, so now we're well into the New Year's. So, Happy New Year's everyone. But anyhow, let's talk about the little graph here. So I have a simple output stage drawn, single-ended. You might say, doesn't single-ended mean single output device? Well, that's true with vacuum tubes, but normally they call this a single-ended stage because one side of the load connects to the output, the other to ground. But that's in contrast to something like a bridged output stage, whereas each side of the output's connected to an output stage. But anyhow, I'm showing the positive rail voltage here, the negative rail voltage, and at no signal the output will be at 0 or centered between them. And of course when it has an output signal it will swing between those rails. Now due to the topology of the amp and losses in the output stage, such as with the resistor and a little bit across the transistor, the clipping limit of the amplifier will be somewhat less than the supply rails, and that's what I shown here kind of arbitrarily on the graph. So as you see here, as the waveform goes above that, it starts clipping, chops the top off. So I need to take this into consideration when selecting the power supply voltage. Now with the JAT801 amp, using my supply at its maximum limit, plus or minus 32 volts, and driving a 4 ohm load with the amplifier, I calculated slightly less than 5 volts drop from the rail to the actual clipping point. Now with the paralleled output stage of the 801, I won't lose as much voltage, but I will be driving it at higher power, so I'll still have to estimate some loss there. So I'll estimate about 4 volts. So let's say I want to select a power supply voltage that will give me 150 watts of output into an 8 ohm load. So here's how I'll go about calculating that. Okay, math time. Everybody likes math time, right? Just like school again. Don't you want to be back in school? Oh boy. Okay, well this is not too tough. Okay, so we take the square root of the power times the load impedance times 2. And we have that 2 in there because we're looking for voltage peak. Without that, we would just get RMS. So if we want 150 watts out into 8 ohms, we're going to get a peak voltage of 48.9 volts. We'll just say 49 volts. And I have to add that 4 volt of dropout to that. So we take 49 and add 4 to that in the case of the 801 amp, and the voltage rails would be plus and minus 53 volts. Now, one thing you have to look out for is if you want to also drive 4 ohm loads. With that power supply voltage, it's going to really increase the current. Now, if that power supply voltage were regulated in some way so it would stay the same, it would stay at 53 volts, we wouldn't quite double the power into 4 ohm loads because you increase the losses in the amplifier. You still might get, I'd say, somewhere around 250 watts. So you'd have to be careful to make sure you're not exceeding the safe operating area of the power transistors. In real life, you may not be using a regulated supply. Normally you don't with the audio power amp, and your power supply voltage is going to drop more with the heavier load as well, and it might drop back to probably around 220, even 200, depends on your transformer load regulation. So if I also want to use 4 ohm loads with the amplifier, I'd drop back to 120 watts into 8 ohm loads. So when I do use a 4 ohm load, I'll probably get around 200 watts of output. That's how I come up with that number. Well, I think that's going to do it for this one. Thanks for watching. Appreciate the support. We'll catch you in the next video.